Alright guys, this section is going to cover lesson 5.3 in our book. It's experimental probability of compound events. Let me pull my visor up because I went ahead and did these ahead of time. Alright, so in this one you're going to do an explore activity first off. So you're going to need to make sure that you get a coin and a number cube from the table over by the window. I will have them set out for you, so just go get it when you need it and whenever you're ready. So, exploring compound probability. A compound event is an event that includes two or more simple events, such as flipping a coin and rolling a number cube. A compound event can include events that depend on each other or are independent. Events are independent if the occurrence of one event does not, keyword not, affect the probability of the other event, such as flipping a coin and rolling a number cube. No matter what happens on that coin, it's not going to affect what happens on your number cube. It's just not going to happen. So, letter A says, what are the possible outcomes of flipping a coin once? Well, you can get heads or tails. That's it. That's your only options. B says, what are the possible outcomes of rolling a standard number cube once? This is just a die, guys. It's 1, 2, 3, 4, 5, 6. We should be familiar. We've been using these. C, complete the list for all possible outcomes for flipping a coin and rolling a number cube. So both. Whenever you do it, you could get heads with 1, 2, 3, 4, 5, or 6, and tails with 1, 2, 3, 4, 5, or 6. Make sure you list them all out. That's what the question is asking. Don't just make up your own stuff, guys. Do it like it asks you to do. Okay, so there are 12 possible outcomes for our compound event. So, what you're going to do now is you need to flip a coin and roll a number cube 50 times. Use tally marks to record your results in the table. So my table is blank because this is something that you are personally going to do. Like I said, the number cubes and the coins are over on the table. Make sure you get them and use them when you need to. If you happen to have someone in your group who is the exact same point as you are in our unit, then you are more than welcome to work this together as a group. I'm completely okay with that, but only pairs. Not the whole table, not 4 people, not the people at the table next to you. With a pair, meaning 2 people at the same table sitting next to each other. So, based on your data, which compound event had the greatest experimental probability, and what was it? What was the least experimental? Well, I don't know what your data is, so you're going to have to look at it. Once you get it, let me know. I will come around and check it, and I'll look over and make sure everything is okay. So then, draw conclusions. Did you expect to have the same probability of each possible combination of flips and rolls? Why or why not? This is you, okay? This is how you need to handle these questions, not me. But no, 50 trials is not enough for your result to really be close. When you look at your data, you might get lucky on a couple of them, but all of your possible outcomes should not have the exact same probability. That's not with 50 chances, okay? Turn the page. Alright. Calculating experimental probability of compound events. So, the experimental probability of a compound event can be found using recorded data. So, example 1, we're going to walk through together. Let me slide down a little. A food trailer serves chicken and records the order size and sides on their orders, as shown in the table. What is the experimental probability that the next order is for 3 pieces with coleslaw? So take the time, pause the video if you need to, read over your chart. Step 1, find the total number of trials or orders. So that means add everything up. You end up getting 330. Find the number of orders that are for 3 pieces with coleslaw. Okay, so you have to go through 3 pieces with coleslaw. Should be 55. Find the experimental probability. So you have the 3-piece plus you have the coleslaw over your total number of orders. So you should have 55 over 330, which is going to simplify to 1/6. Your experimental probability that the next order is for 3 pieces of chicken with coleslaw is 1/6. So make sure you really read this example in order to help you on the your turn. So pause your video. When you come back, check your answer. You should have the same answer. If you do not, please go back and review the previous example. Your turn number 1. Drink sales for an afternoon at the school carnival were recorded in the table. What is the experimental probability that the next drink is a small coffee? Well, coffee is 60 out of 400 total orders. You had to add that up, show your work. When we simplify, we get 3 out of 20, which ends up being 15%. We have to know how to convert fractions to decimals to percents at this point in the year, guys. If you're still struggling, make sure you get it and get the help that you need. Next. Maybe. There we go. Alright. This one is using a simulation to make a prediction. You can use a simulation or model of an experiment to find the experimental probability of compound events. Example 2. At a street intersection, a vehicle is classified either as a car or a truck, and it can turn left, right, or go straight. About an equal number of cars and trucks go through the intersection and turn in each direction. Use a simulation to find the experimental probability that the next vehicle will be a car that turns right. So, step 1, we need to choose a model. What kind of model do we want to use? We're going to let a coin toss model the 2 vehicles. So heads can be cars, tails can be trucks. If you would like to use a manipulative, meaning you want to use your hands and do this with it, get a coin from the table by the window. That's what they're there for you to use. Okay, I'm going to use a spinner divided into 3 equal sectors to represent the 3 directions shown. You've got left, right, and straight. Step 2, find the sample space for the compound event. So there are 6 possible outcomes. You could go, car could go left, right, or straight, and then a truck could go left, right, or straight. That's what each of those represent. Now you need to perform the simulation. A coin is tossed and a spinner is spun 50 times. The results are shown in the table. So do you need to spin it 50 times and toss your coin 50 times? No. It's done for you. They are giving you a table. Please don't waste the time in class when they're giving you the simulation results. They're not asking you to do the actual experiment. It's done for you. So, this is your table from the results. Now we can find the experimental probability that a car turns right. So a car turning right, we have 6. Out of 50 total cars, it is going to be 3 out of 25 as a fraction. Remember, you could turn this to a percent. Percent means out of 100. So if we multiply the bottom by 25, we multiply the bottom by 4, we multiply the top by 4. So 25 times 4 is 100. 3 times 4 would be 12. This would be 12% if it asks you for percent in one of your questions. Now, pause the video. When you come back, you need to have the reflect number 2 answered on your paper to check. Remember, we're not copying my work. We are doing our own and then checking it to make sure that it is correct. Reflection number 2. Make a prediction. Predict the number of cars that turn right out of 100 vehicles that enter the intersection. I would set up a proportion here, guys. That's why we learned them. So I'm thinking that it will be 12. If 6 out of 50 turn right, then if I multiply the bottom by 2, because they want to know out of 100, I multiply the top by 2. 6 times 2 is 12. There's your answer. You're good to go. Alright guys, last one. You've got your turn number 3. And then it's on to guided practice. Your DIY for this is going to be guided practice again. So, your turn number 3. A jeweler sells necklaces made in 3 sizes and 2 different metals. Use the data from a simulation to find the experimental probability that the next necklace sold is a 20-inch gold necklace. When do we sell 20-inch necklaces? Excuse me. Okay, we've got 12 out of 75, and when we simplify, you need to get 4 out of 25. Let's see here. If you have any issues, this is it, guys. This is the end of your section. So if you have any issues, please be sure that you let me know, and I will be more than happy to help you out. It's your turn to now complete the guided practice for this section. Thanks for watching, and good luck.